You make sure that you do it booting off of a Linux Live CD or launching a VM so that you know that someone can't steal your credentials. Anybody? No? Not willing to admit it, right? So every day we click on different things and assume a certain level of trust and safety. Earlier this year, I was looking for a car back in the March timeframe, and I went to leasetrader.com. I was using my wife's laptop, and I thought nothing of it. I was searching for cars and going about my merry way, and left the computer and walked away. About a week later, I went back and I realized that there was a drive-by download hosted by leasetrader.com on that specific day. And I took a look at what that drive-by download looked like, and it was a little bit disconcerting to me. That malware that complex and potent could actually hit my particular machine. And this is what the malware did. So I clicked on leasetrader.com on Friday, March 15th at 9:16 a.m. It then went out and invoked a couple of different processes. You can see here in the lower left-hand corner that it invoked the Java plugin launcher, which then invoked java.exe, which then invoked a command shell, followed by registry server 32, which, if you're familiar with that, it actually registers DLLs to the Windows kernel, telling them that they're legitimate, which then dropped and executed that file with that MD5 hash. And needless to say, it went on and made some modifications to the registry, and once in a while we'll see privilege escalations and other such thing, and made a lot of connections to the internet, so it turned out to be a clickjack attack. Now the funny thing is, I didn't care. And that's not because it was my wife's laptop. I didn't care because my hardware was protecting me. The CPU itself was ensuring that all this malware, along with the entire contents of the website, was completely locked away in a secure, hardware-enforced container. Now, if we rewind 15 years ago, back in 1998, the founder of Bromium, Gaurav Banga, was working at NetApp, at vFiler. Another founder of Bromium, Ian Pratt, was at Cambridge University as a professor in the computer science department, along with the third founder of Bromium, Simon Crosby. Now, Ian is considered the father of Zen. He created Zen way back then, which he then later founded ZenSource with Simon Crosby, fellow professor. The two of them then sold ZenSource to Citrix, which now powers all of Amazon, AWS, EC2, etc., as well as Gmail and Rackspace and a number of other large public clouds. So Zen, similar to VMware's hypervisor or Microsoft's Hyper-V, is what provides a lot of the virtualization, certainly the open source virtualization, for much of the cloud space. Now, how does this apply to me clicking on some random website out there? Well, Gaurav called Ian and Simon back in 2010, and they put their heads together to come up with this particular idea of what if we could create a secure solution that, regardless of whether or not a website contained a drive-by download or an email attachment contained a screen scraper or a bootkit, regardless of those facts, wouldn't it be great if we could provide something that was so secure that it would take an attacker physically attacking to be more effective than what they could do against the hardware itself. So they developed this Bromium vSenty concept of micro-virtualization. Now, the concept of micro-virtualization is based on two premises. Number one, you really can't detect what's out there. I myself am a security guy, and yet I had no clue that the website I was visiting was infected. Now, if you're watching a bunch of people frolic out in the ocean and they're all surfing with dolphins, you're going to think it's pretty safe to go out there, right? But if you saw this guy all alone by himself, you might think differently. Maybe that's not a dolphin, right? Humans write code, and therefore code will always contain vulnerabilities. Humans are also the ones who open attachments and click on links, and therefore we will always be exploited. those two unchangeable, immutable facts combine to threaten us using the following threat vectors. They get in and steal certain credentials, or once the attackers are in, they're able to move laterally and siphon out the most valuable company IP to foreign countries. And this is how they're doing it. Users surfing with Java, Adobe Flash, opening email attachments, downloading web documents, or launching documents off a USB device. That's how they all get in for the most part, 90-something% of them. So this concept of micro-virtualization is built on what's called a microvisor. It's different from a traditional hypervisor in that it is stripped down and security focused. It's very lightweight. And the whole purpose is to create a hardware boundary between all the untrusted tasks that you're doing on your PC and the rest of the desktop system. Now we're leveraging certain capabilities on the Intel chips to be able to do that. First and foremost, we're using Intel VTX. Now the VTX circuitry is there to perform one single function, and that is to apply the concept of dynamic least privilege access control. Or in other words, need to know. If I download some random Excel spreadsheet from the internet, okay, let's do that right now. Let's launch Chrome, and we'll just type in file type XLSX with sites that are only Russian, site:*star.ru. I don't even read Russian, so I have no idea what these say. And I'll just click on whatever random link is here. Again, I've downloaded several of these, and some of these I've never downloaded. And if you look at the folder, it's actually sitting right here on my desktop. So let's minimize everything for a moment. You can see that nseta.xlsx is sitting on my desktop there. And it really is the file I just downloaded. There's no smoke and mirrors here whatsoever, I promise. But you can see that the creation, modified, and access dates are all right here, right now, what I just did. Now the difference here is that you can see it's an untrusted file. Right? Does anybody here in the room know if this file is malicious? Please raise your hand if you know, because I don't. And our premise is that nobody does. Your AV vendor doesn't, right? Your HIPS, NIPS, or sandbox detection vendors don't either. Nobody can really say for sure if this is malicious or not. Our response is, hey, neither can we, but we don't care. So I'm going to go ahead and launch this particular document. But before I do, I have something here on the right that's called the status monitor. This status monitor, its sole function, without it, you would have no idea what was going on. But its sole function is to be able to demonstrate to you, behind the scenes, this concept of micro-virtualization or hardware isolation. So when I double-click on this particular Excel spreadsheet, it opens in what's called MicroVM number 17. Right? So each of these little micro VMs are hardware enforced by Intel VTX to restrict the view of whatever's running in these little micro VMs to just the least privilege, just the bare minimum resources that are needed to render, in this case, the Excel spreadsheet, or render a web page, or a document launch from the USB device. Okay? So if I go into, click on some email, right? Here's an email that was sent to me a short while ago by a colleague. I click on this link, and that opens in MicroVM number 18. It's a darkreading.com article. And I can scroll down and copy and print and do whatever I normally would do. But the difference here is that the actual website itself has been rendered inside of what's called a micro-VM and then stitched back into the frame of the browser. So from a user's perspective, they're just reading an article. And they can click on anything. If I scroll up to the top and click on this banner ad up here, you can see down here it says adtechus.com in the lower left-hand corner. So this isn't the same domain as darkreading.com. So if I click on that, notice that MicroVM number 19 just got created, and then 20. And that was just a redirect from adtechus into the final website of techweb.com. Okay? So each individual web page is rendered in its own micro-VM. Each individual email attachment, each individual web document, whatever I download or open or click on gets rendered in its own hardware-enforced micro-VM. Now let's talk about the properties of some of these little micro VMs. First of all, the user experience is unchanged. If I, for example, want to change cell B14 here and say, hello, security meetup, I'm going to go ahead and close this Excel spreadsheet. We'll save the changes that I just made. And that particular micro VM just got destroyed. Now, if I launch that same Excel spreadsheet again, that's MicroVM nerd 21. We don't need to go back and recycle these old micro VMs because what we're doing behind the scenes is just a fast clone of what's already running, but with that restricted view enforced by Intel VTX. Okay? So you can see that my change is saved. Cell B14 is different. We securely wrote the changes down to the disk, but anytime they're executed or rendered, they're done in a separate micro VM. In other words, I can keep calm and click on anything. Okay. Now let's go inside of a micro VM, inside of this MicroView nerd 21, to talk a little bit about this concept of dynamic least privilege. I have a special developer mode keystroke here that allows me to go inside of these micro VMs. A normal user would not be able to do this. But when I launch this command shell, first of all, you notice that when I move the window, the actual command shell moves with it. And if I try to move the command shell outside of it, I can't. So this command shell really is inside MicroVM number 21. Now, should a random Excel spreadsheet that I got from some Russian website have access to the internet? No, it's kind of a bad idea. Command and control servers, etc. So if I try to ping google.com, for example, notice that I'm unable to. That's that concept of least privilege. Until VTX is saying, hey, this spreadsheet shouldn't have access to the internet. It came from the internet. It's not trusted. So let's not let it talk to the internet. Is there a question?
Yeah, what about if you have, like, let's say a web page you're working with and you put it into this micro-VM, and it happens to be like using like Rocket.js, which is connected to a Mongo, which is a super fast database exchange so you can get an interactive page. Will that break that page?
Is that all served up from the same web server, or is that served from an internal? It shouldn't, because
from an external server, you know, you're talking about data coming in, and it's super fast interchange. Would it break that page?
No. I mean, we have, if you go to, let's say, ESPN.com, there's 13, or I think almost a dozen different sources of third-party JavaScript that are being loaded from different servers, and that's all being served up to ESPN.go.com, which is owned by the Disney Network. So it's not going to break that page, even though there's multiple sources of third-party JavaScript, or multiple sources of that page being stitched together to appear as one. Okay. Now, what if I want to poke around in the internal file system inside of this particular micro VM? So I'm going to show you what's inside of the program files. And if you compare inside of these micro VMs, that with what's running on my real desktop, okay, so you can see here that the green font on the right is my real desktop system. The red font is what's inside the micro VM. If I try to ping google.com here, notice that I can. Okay? At least it resolves. Maybe ICMP is disabled here. But the important thing here is that the hardware is restricting what this untrusted piece of content can do. All right? If I try to do that same command to show you the program files directory, you'll notice that within the desktop, for example, the Lenovo folder or DVD Maker or the Windows Mail folder, those are simply not needed to render the Excel spreadsheet, so we don't bother to reflect those into the MicroView.
Is that something that someone configures for the MicroVMs per application, or what if there's something that does need to be used that maybe is not traditional?
Okay, so the question is that configured per application, or is there any control over that? We've actually taken the time to figure out what's needed to render spreadsheets and PDFs and Word docs and web pages, and we've included what's needed for each of those tasks. Now, if there is something out of the ordinary, we could potentially allow that in. We've done that for certain kind of custom corporate environments where that might be needed. But for the most part, when you're getting something from the wild, wild west known as the internet, you're just going to open it to render it and maybe manipulate the data inside it. It's not necessarily going to try to connect to some external service.
And if the page that you're browsing to does in fact need Java to run,
That's fine, no problem.
It's still invoke it, but within the...
Just within that micro VM. But it can connect to whatever else. It can connect out to a command and control server, pull on more malware, and drop and execute that. But it's all contained within that micro VM.
It can't overwrite into the main OS.
Excellent, thank you. That's exactly where I'm going. Okay? So this concept of least privilege means that I can't access the internet if I'm an attacker inside of some Excel spreadsheet or some random web page if I'm trying to access the local file system, because why should I need access to something that might be sensitive, right? Let's go into the users directory really quick. So if I cd inside of this little micro VM into the users directory, now you might know this as the SAM accounts database, right? You can see that there's clearly a limited view here. So Frank, he's a guy that here at Bromium, one of my colleagues, and Joe, that's me. Those are our user accounts. But should those user accounts that have sensitive access, sensitive data, including my password, my corporate domain password, right, be visible from some random spreadsheet that I got from Russia? And the answer is no. So we actually have a completely fake SAMDB, SAM accounts database inside of these micro VMs. Right. Now the question back there was, well, what if the bad guys want to overwrite something? And that's where Intel EPT comes into play. Intel extended page tables is what we use to allow the attackers to make any modifications they want within the context of these little micro VMs. How many of you are familiar with the Unix fork command? Anybody? Okay. That's essentially what we're doing. So when a child process forks off the parent, it's copy on write back to the original memory, right? The memory address space. So if an attacker comes in here and they want to look for, let's say we're going to dir Windows system NTOS kernel, right? Oops, he's 32. Sorry. There we go. If they want to modify the actual Windows kernel, we let them, because any changes they make here are written to the Intel extended page tables, which are mapped directly to the memory pages of just this micro VM. So in other words, when the attackers get in, there's nothing sensitive, no sensitive part of the registry, no sensitive part of the file system, and any modifications they make are mapped just to the underlying file system. So they think that they've injected something into a DLL. They think that they've stomped on a Windows memory page or modified the kernel itself or exploited it. That's fine. And within the context of that micro VM, they have. But this microvisor runs underneath the Windows kernel. So again, no harm, no foul. We literally tell the attackers, hey, come on in, the water's warm. There's nothing that they can do to harm us in any way. So copy on write, if I cd back into that fake user's desktop, and I want to, for example, create a directory here called Keylogger. Why not, right? You can see here that there is a Keylogger directory. If I cd into that Keylogger directory and show you what's inside, there's nothing there. Okay. Now I'm going to go ahead and echo start Keylogger, and I'm going to dump that into keylogger.bat. So now you can see that there is a fake 18-byte keylogger inside of this micro VM. Again, Intel VTX is enforcing this dynamic least privilege, and Intel EPT is ensuring that any changes I make, such as creating a fake keylogger, are housed only and mapped only into the memory space of that particular micro VM.
Question.
Yes?
So when you're done with it, all these files are going away?
No. Malware cannot persist. And that's why when I went to leasttrader.com, I just laughed.
So how do
Moved
I
on.
save a good spreadsheet I got from the internet on my physical C drive?
No, that's what I just did. So you can see here that I got this Excel spreadsheet from the internet. It's a Russian spreadsheet, but I still wrote something into cell B14 here, and when I saved it, it still wrote it down to the hard drive, But whenever I go to open that Excel spreadsheet, it's been tagged with its data provenance information. It knows the spreadsheet. I can make changes all day long. I can change formulas and can do pivoting tables and create a macro, whatever else I want to do. So the point here is it always and only can get rendered.
So if I delete malware on my physical drive, the only way to access it will be protected.
Yes, exactly. The statement there was I can actually then have malware on my physical drive, but I'm always protected from it because every time I execute it, it opens in one of these hardware containers, and that's correct.
What will your AV do when it hits that file?
Oh, it'll see it. It'll say, if it knows it, it'll say, oh, you got a malicious file here. And if it has a false negative, meaning it doesn't look bad to me, right? No harm, no foul. It's not going to delete it. It's just going to leave it there. But you're still protected if you're using this type of hardware micro-virtualization, hardware isolation.
One question. Can you have a micro-VM, like running the macro from another spreadsheet on your location?
So can you have a micro-VM that's running a spreadsheet, run a macro that connects to something else?
Yeah.
No.
Different micro-VM.
No. Eventually we're getting to that point. We're going to get to a point where you can create granular policies to say, let PDFs that come from this location talk to this IP address or talk to this other location on the internal file system. That's just a matter of building a policy engine in place. That's not there today, but today you can certainly do what I've just shown you by editing, copying, printing, and making modifications to files to share them with others. Another question? Yeah, go ahead.
Yeah, so you're in Excel right there, and what if you're done with that version file and now you want to open your personal account Excel spreadsheet? Do you have to quit Excel and basically reopen the file? How does that work?
If you want to create something brand new,
Like open another existing spreadsheet, but from within that view. Like the way I use Excel, basically, I put it to file open, and then I'm going to browse my home directory and find my spreadsheet.
yeah, you could do like a file save as here, but what you see here, when I'm presenting the desktop, this is not inside the micro-VM, because you can see that I'm clearly outside of it. So the microvisors actually paused that little micro-VM and said, okay, Mr. User, where do you want to save this file, or where do you want to open a new file from, or whatever it is,
Right.
present it outside of it, and then whatever I choose to do, it'll either render that into a micro-VM or save it down to the hard drive.
Are any files ever trusted?
Yeah, sure, like stuff that I created.
Determination.
Yeah, so if you can see here on my real desktop, there's a bunch of files here without this little orange BR logo, and that's just window dressing. If you don't want the orange logos there, you can make them go away, but they help to differentiate between what came from the internet and what came from some internal source. Like there's a lot of files here that I created. This one, I created that one, those Word documents. So anything without that orange BR logo, I'm the creator for, and therefore I trust those, so there's no point in opening them in a micro-VM. Okay. Another question back there?
What type of resource impact does this have if you're firing up all these VMs?
Excellent question. So we're going to go ahead and launch a bunch of micro-VMs. And you can see here, if I launch 100 micro-VMs, there's the PowerShell script. Let's launch Task Manager. You can watch the performance here. We'll bring the PowerShell script down there. We'll launch the Task Manager here. Let's bring that up. And let's also show you the status monitor so you can watch the incremental micro-VMs or number of micro-VMs grow. So down here you can see that there's 9 micro-VMs currently. And just as importantly, you can see the memory here is hardly going to grow. So I've got a bunch of applications open. I've got WebEx, I've got Outlook, I've got IE, Chrome, I've got the Office suite. There's a bunch of things that I'm opening and using here. But the beautiful thing is that even though I can have 100 micro-VMs open, I don't know why that keeps disappearing on me, I can go up to 5, maybe 5.5 gigs of RAM used, and we're actually extremely memory efficient in the way that we manage the memory and the rendering of those websites behind the scenes. So I've had over 100 micro-VMs open, and the performance is as if I had 3 open. I mean, it's just lightning fast. I click on stuff, I scroll down, click on other things, and that's all because of the memory efficiencies that we've gained over the last 15 years in the development of Zen.
Actually, try doing that
without Bromium. I have in 25 tabs and IE open and see the performance there. We actually increase the performance of the browser.
Question?
The magic
What
of this
if
is,
the document doesn't come from the internet? What if it comes from like a USB or like a Windows share?
Same thing. If I plug in a USB device right here, whatever I'm exposed to in the file system of the USB device would be untrusted. So whatever document I double click on would open in a MicroVM. But you can choose by policy whether you're going to allow certain USB devices or not trust any of them, for example. Another question?
you're getting memory from somewhere. Is this just going on like making a virtual memory or like a swap memory to the hard drive?
Mm-hmm.
I mean, because you have 100 VMs, where's the memory actually be? Hard drive?
So it's copy and write. If you're familiar with the Unix command, there's no, when a child process is created, it doesn't copy the entire memory address space of the parent. When it makes some modifications, just the delta of the memory block or the disk block is mapped into its own memory. And everything else gets mapped back to the parent. So that's what we're doing here. There's a ton of common memory behind the scenes. It's shared memory. But anytime anything goes to make a modification, it's copy and write enforced by Intel EPT. So again, nobody can step on anyone else's memory because they're different machines as far as these micro-VMs are concerned. And that's why we can have an incredibly efficient usage over time. You can see the steady state memory right here. Okay? Unless there's some super intensive site which spikes for a second, but then it goes right back down. Another question?
So is this only for Windows operating system or just...
Today's for Windows. Shortly you'll see releases for Mac OS X and even some mobile devices next year.
No Linux?
There's not a lot of threats out there for Linux, but actually the first prototype of Bromium was built on Linux. So that'd be trivial for us to do. We're just not seeing enough demand for it yet.
Curious. So with other devices in the Mac uses, but I guess I don't know a whole lot about the instructions or the Intel features that you're making use of. You know, those are really common.
Very common. So any Core i3, i5, i7, any CPU basically that Intel's manufactured over the past 4 or 5 years would have these VTX and EPT extensions in them, as well as most recent Xeon chipsets on the server side. Now, one last thing I want to show you was if I do go to those malware sites, you saw that earlier lava event, right? And I went to one this morning, right? We have here at Bromium, we share malware with each other. It's kind of funny because when any one of us encounters malware, we call it fresh meat, and we send it out to each other. You know, most of the time, if there's a fire, people run away from it. We actually run towards it, because we can. I'm running Java 7 Update 5. I've never updated Java in the 16 months I've been at Bromium, because I don't need to. Why patch? If I need functionality, I'll patch. But there's no more security risk to me, because my CPU is what's protecting me now. Not the kernel, not any other software. So, this morning I went to this particular website, which was up on malwaredomainlist.com. And again, what we've done, in essence, is we've turned the table on the attackers. Instead of them leveraging vulnerabilities on my endpoints, on my PC, my operating system, Java, Adobe Flash, whatever it might be, and then from that exploit, moving laterally to other machines in the network, and then from there, exfiltrating data out silently, I can pull up a chair, grab a pina colada, and just watch what the attackers are doing. In fact, I can toy with the attackers because my CPU is protecting me. So we are isolating instead of detecting. In other words, we do not need to detect in order to protect. We're doing this at the individual task level. Instead of taking the entire browser and throwing it into one big VM or one big sandbox, which does not protect you from cross-site request forgery or cross-site scripting or other man-the-browser attacks. We're taking each individual task, rendering it in a MicroVM and stitching it back into the user's UI so they can't tell whether it's in a MicroVM or not. And then finally, we're leveraging hardware to do this. So even if there is a Windows kernel vulnerability or a Java 0-day, we just don't care. It's all rendered in the MicroVM. The CPU is enforcing from VTX and EPT the concept of dynamic least privilege and copy on write. And then we get all this critical threat intel. So we know what attackers are trying to do. we can see very clearly their dropped and executed files, their attempts at privilege escalation, their registry modifications, and the IP addresses that they connect to these micro-VMs from. We harvest it all, and we can use this critical threat intel to protect all the other systems on the network or in the data center. So the future is micro-virtualization, hardware isolation, happy circuitry.